your absolute value inequalities are going to be solved practically the same way that we solved absolute value equations. We have the same 4 steps. There's just some minor difference. Step number 1, we are isolating the absolute value. Step number 2, we're going to be making 2 inequalities like we did with our equations, but the big difference is this time when we use the same sign, we're also going to be using the same inequality for one of them. And when we use the opposite sign, we're going to make it the opposite inequality. And you guys will see what we're talking about when we start with example 1. Step 3 says to solve both of them. And then step 4, very important, check your answer. And if the directions call for it, you're also going to have to graph these. So we'll practice graphing with our examples today as well. Okay, example number 1. They've already done the first step for us. Our absolute value is already isolated. So let's move on to step number 2 here. Step number 2 says make 2 inequalities. So we're going to drop our absolute value. We're going to use the same sign for 4 and the same inequality that we have in our problem. So we're going to write greater than or equal to positive 4, since that's what we've got in our original problem. Our second one is going to be v minus 3, the opposite sign for 4. So we're going to use negative 4. And this time we're also using the opposite inequality. We're going to have to flip that around. That's going to turn into less than or equal to. So that takes care of step number 2. Now it's time for number 3, solving both of them. Let's add 3 on both sides. One of my possible solutions, I'll have v is less than or v is greater than or equal to 7. And my other solution will have v is less than or equal to negative 1. That takes care of step number 3. Now it's time for the important step of step number 4, checking our answer. Now this time when we check our answer, we're actually going to have to follow our inequalities. So let's look at our first solution. We have v is greater than or equal to 7. Since it's greater than, let's pick a number that's greater than 7. And you can choose any number that you want to. I'm going to go for something that's relatively simple. Let's just go with 8, because we know 8 is bigger than 7. And we're going to take 8 and plug it back into our original problem here. So let's have an 8 for our v. And we'll have 8 minus 3 in the absolute value is greater than or equal to 4. And let's check to make sure that this is true. 8 minus 3 is 5. Absolute value of 5 is 5. And 5 is greater than or equal to 4. So this solution works. I know that I've got this one for one of my answers here. Let's try the other one. This time we need v is less than or equal to negative 1. So a number that's smaller than negative 1, we could use negative 2. So let's plug a negative 2 in for v this time. And notice I'm going back to the original problem, so I'm using the greater than or equal to positive 4 for checking my answer. Now negative 2 minus 3 would be negative 5. Greater than or equal to 4. Absolute value of negative 5 is positive 5. And we end up getting the same thing that we did over here. We know that's true, so v is less than or equal to negative 1 also works. Now it's time to graph these two, and we're going to graph these like we did our compound inequalities. And we're going to put them on the same number line. And if you'll look, we've got 7 and negative 1. Those are kind of spaced far apart, so why don't we make our number line go up by 2's? So we've got 2, 4, 6, 8. And I'll go to the negative 2, negative 4, negative 6, negative 8. All right. So our first one, we've got v is greater than or equal to 7. That's going to be a closed dot at 7, which is right here. And it's greater than, so that arrow points to the right. V is less than or equal to negative 1. Negative 1 is between 0 and 2, and that is also a closed dot. And since it's less than, our arrow points to the left. So we end up getting an OR graph because our arrows are pointing away from each other. Let's take a look at example 2. That'll be our last example for the day. That's a little bit more complex than example number 1, but we can handle it. Step number 1 says isolate the absolute value. We're going to have to do that first. So first thing we're going to move, we have a 4, we have a negative 3 over here with our absolute value. We're moving this 4 first because it is not attached to the absolute value. We're going to move that 4 by subtracting it. Alright, we get negative 3. Absolute value of m plus 2 is greater than negative 18. That negative 3 is multiplying times the absolute value, so let's do the opposite and divide. Now I'm dividing by a negative, so we're going to have to flip our inequality over, and we've got absolute value of m plus 2. Negative 18 divided by negative 3 is positive 6. Okay, that's step number 1, isolating the absolute value. Step number 2, break it into 2 problems. We drop the absolute value, keep the same inequality, and keep the same sign. So we've got m plus 2 is less than 6. The second one, we're going to have m plus 2, but this time it's going to be greater than negative 6. Alright, step number 3 says solve both. Let's subtract 2. And that will give me m is less than 4. For the other one, we're subtracting 2 as well. And we're going to have m is greater than negative 8. Okay, we have to check both of these. Now, I'm going to give you a little shortcut here. Rather than having to go back to the original problem, because this one is pretty long, you can go back to the part of the problem where you've isolated the absolute value. So instead of plugging it into the original problem, I can go back here as long as the absolute value is by itself and plug in our guesses here. So let's start with this one, and we'll start with our solution m is less than 4. A number that's less than 4 is the number 2. So let me try 2. I'm going to put 2 in place of m. So I'm going to write 2 plus 2 is less than 6. Let's check that. 2 plus 2 is 4. Absolute value of 4 is 4. 4 is less than 6, so I know that this one is a good solution to use. Okay, let's look at this one. M is greater than negative 8. A number that's greater than negative 8 is the number 0. So let me try that. I'll plug a 0 in place of m. So I've got 0 plus 2 is less than 6. 0 plus 2 is 2. And the absolute value of 2 is 2. 2 is also less than 6. So I have another solution that works here. So both of my solutions that I've solved for work. Now let's go ahead and graph them. And again, they're kind of spaced far apart with negative 8 and 4, so let's go up by 2's here. Alright. For our first solution, m is less than 4, that's going to be an open circle on 4. And the arrow points to the left. And I'll make it go all the way to our negative 8 here. Negative 8 is going to be an open circle. And its arrow is greater than, so that's going to go to the right. So in this case, this absolute value inequality ends up being an AND graph. So moral of the story is, when you're solving and graphing these absolute value inequalities, you can have OR graphs or you can have AND graphs. You just got to be real careful about which way you're solving these. You will never have an arrow that points the same way for both inequality solutions. So both of your arrows will not be pointing to the left, and they're not going to be pointing to the right either. So be very careful about that. That's a good way to check yourself. And that will conclude our absolute value inequalities video.